In this video, you will learn how to write an equation from a proportional relationship graph. As we've been talking about, when you have a proportional relationship, if I take the y and divide it by the x, that ratio is going to be the same thing. So we can apply that when we're looking at a graph. So if we look at the first one here, and you should have the paper as well so you can follow along and so you can do the same thing that I'm doing in the video on your paper. We're looking for points on the graph that we can use. So I'm going to start with just the first point here. And I like to do these things, I kind of think of them as stairs. So right here, the y is always our movement up and down. And the change here is a 6. So it goes up to the 6. And then the x is the movement this direction, because this these down here are our x coordinates. And if I go over this direction, I'm moving over 1 on the x. So if I look at my y over my x, I have 6 over 1, and that equals 6. That 6 is what our unit rate is, or like we've talked about before, that unit rate is oftentimes called the constant of proportionality, the number that we always get when we simplify that ratio, or what we'll begin calling the slope this year and next year. The other thing about a proportional relationship graph is that I can go between any 2 points on the graph. So I could choose this one here and this one here, so a little bit further apart. And so if I look here, the change going up in the y is going to be a value of 12. And then if I go over to this point here, that changes 2. So see, when I take that y change divided by that x change, once again, I get a simplified answer of 6. So that 6 is going to be our slope, or constant of proportionality. Remember, we've talked about how the equation for a proportional relationship is y equals mx. So that 6 is going to be our m. So when I write my equation, I'd have y equals mx for my answer. If I go over to this next table, I can use any of the points that I'm given here. So I'll just use these first couple, and if you look here, we're looking at how much did that y change. If I go from, now you got to look at these numbers over here because we aren't always counting by ones. I'm going from 120 to 180. That change is going to be 60. If I go from here to here, I'm looking at these numbers down here, and I'm going from 2 to 3. So that is going to be a change of 1. When I simplify that ratio, that's going to be 60. So 60 is going to be my slope, or my constant of proportionality. And then when I write my equation, 60 will go in the place of the m. I also just noticed that over here, I put that m in the place, and that should actually be the 6. So I'm going to go back and fix that. Make sure you've tried that on your paper as well. On this next graph, the difference that you may notice is that there's not any points that are actually plotted on the line. If this happens, what you need to do is what I call find the nice points. The nice points are going to be where the line crosses on these intersections. So see where, like on my graph paper, I have these T's that happen. This right here would be a nice point because it would have a nice whole number for the x and for the y. So if I'm looking at the line for some of those nice points, I would be able to find a few different ones. Like right here would be a nice point, and right here and right here. See how the line crosses at those intersections? And so once I get those points, then I can look at what that change of y is and the change of x is. So if I look at this from 400 to 800, it's going to be 400. And then if I go over, when I look at the x-axis, you can see I'm going from 20. This line right here, it would be halfway between 20 and 60. So that would be 40. So if I go from 20 to 40, it's going to have a value of 20. And when I simplify 400 divided by 20, I end up with 20. Now, I just want to show you if I would have chosen some different points. So if I would have gone up higher here in the graph and maybe chosen this one and maybe up like here, so points that are further apart. Same thing, if I look from here to here, I'm moving from 2,000 up to 3,200. So that would be a change of 1,200. And then when I go from here to here, that's going to be a change from 100 to 160, which is 60. So when I simplify that, I divide y by x, 1,200 divided by 60, it gives me 20 once again. So remember, any 2 points I choose on my line, if I look at that change of y over the change of x, I'm going to get that same number, that same ratio simplified. So my slope, or my constant of proportionality, is 20. And when I put that into my equation, it'd be y equals 20x. Now on this next one, first of all, the points are a little bit off. So if you want to ignore the black points up here and just look at the blue points that I drew. So maybe fix that on your graph as well. And then I'm going to look for my change. So I have the points here, and I can use if I'm going from 0 up to 20, that's my change of 20. And then if I go from here to here, I have a change of 1, which is equal to 20. If I would keep doing that, you can see that that change happens again and again. It's up 20 over 1, up 20 over 1. So every time I'm going to get that same slope, or that constant of proportionality. So that would be 20. And then my equation is going to, just like the other one, I guess, be y equals 20x. So these next two are, once again, just a little bit different. We have a line, and it's going to cross all 4 quadrants of my graph, and it's not numbered. If a graph is not numbered, we're just going to assume that it's going up by ones instead of something else. So I'm going to be counting by ones for every time I go up or over. So once again, I don't have points that are plotted. So I'm going to look for a couple points that I can use. Maybe I do my origin, and then I could also do this one. So if I look at what the change was, it went up 1 over 2. So my change of y is 1, and my change of x would be 2. Now if I would have chosen a couple other points, let's say I'm looking from here up to my origin, and think of it as making a bigger stair. It goes up and over. This change would be equal to 2, and this change, if I count 1, 2, 3, 4, would be 4. So if you notice, these two are proportional. Half is equal to 2/4. 2/4 is just another way of writing half. So when I write my constant of proportionality, or my slope, that would be half. And when I put it into my equation, I get y equals half x. Same thing over here. If I want to choose a couple points, I'm going to stick with my origin again. That's a nice one to use. I actually have a point right here that I'm given. I could also use this point, and you can see if I draw those stairs, it's going to look something like this. So my change up this direction is 3, and it goes over 2. Change up here is 3, and once again over 2. So that y over x is equal to 3 over 2. You could keep it like that, or you could think of, for my slope, or you could think of it as 1.5. Sometimes it makes more sense to have it as a fraction. sometimes it makes more sense to have it as a decimal. So we could either have that, y equals 1.5x, or y equals 3 over 2x. For these final two, what I want you to do is try these on your own first. So pause the video, and then once you've tried it, you found the slope, you wrote the equation, turn the video back on and see how you did. So on the first one, you had to find some points that you could use. So I would probably choose this one and then this one. There's not a lot of options. I'd say those are the 3 different points that you would have chosen. And if you look at the change here, you can see if I draw that stair, that change here is 1 and it's over 4. The change of y is 1 and the change of x is 4. So if I write that out, I'd have 1 over 4, which would be my slope. And then my equation is going to be 1/4 x. On the second one, you have a bunch of different options that you could use. So maybe a few things that maybe you are, a couple points that you saw would be these two. If you chose those two, that would be going up 3 and then over 1. So 3 over 1, which is 3. Or maybe you went and you chose this point way up here. So if I did that and use these, you can have a much bigger stair. But if I'm going from 3 to 9, this would be a change of 6. And this here is going to be a change of 2. 6 over 2, which is 3. Or maybe you went way down here and then you used the origin and you made this really big stair. If I look at the change here from 9 going up, I'd get to 0, so this would be a change of 9. And then this direction, I'd have a change of 3 for the x, which is 9 over 3. When I simplify that, I get 3. So no matter what size stair you made, when I simplify that ratio and do change of y over change of x, see how I get the same common constant of proportionality, which is my slope. So I get 3. And then my equation will be y equals 3x. So remember, when you're coming up with an equation from a graph, you're really looking for those nice points to use. And then you're looking to see what is that change of y over that change of x. That's going to be the number that you put into your equation. It's your slope or your constant of proportionality.